Welcome back, everybody. Now we continue with the partial fractions, but this time we are taking another type of fraction. Let's go straight to it. Resolve this fraction into partial fractions. 2x squared minus 3x, 2x squared minus 3x plus 1 over x plus 1 times x squared plus 5x plus 1. Now we can see that this fraction is different from the ones we had in the first in the last video. Here the factor x plus 1 is linear, so we are going to assign a linear factor to its partial fractions. That's just going a constant rather to its partial fractions. That's just going to be a over x plus 1. But the second factor is a quadratic factor. We have to check whether it can be factorized or not. If it can be factorized, we reduce it to linear factors because it's a quadratic factor. So if we factorize it, it's going to have two linear factors. But if it cannot be factorized, then we are going to assign a linear factor to its numerator. So let me check. Can I factorize this? Can I factorize this? I can't factorize this. So that means this factor x squared plus 5x plus 1 is a non-factorizable quadratic factor. So I'm going to assign a linear factor, which is the general linear factor, to its numerator, to the numerator of its partial fractions. The general linear factor is of the form ax plus b, but because I've already used a here, I'm going to make it bx plus c. That's what I'm assigning to the non-factorizable quadratic factor. So that means a over x plus 1. That's actually the trick. If it's a cubic factor, maybe you have something like x cubed plus 7x squared minus 10. This is a cubic factor and it cannot be factorized. So its partial fractions will have the general quadratic factor, which will be ax squared plus bx plus c. That's what will be the numerator of its partial fraction. And the denominator remains x cubed plus 7x squared minus 10. We are going to see more of that as we move on. So here, the second factor is a non-factorizable quadratic factor. So its partial fraction will have a linear factor, bx plus c, and not just a constant, over x squared plus 5x plus 1. So, and that simply means we can combine the two fractions now. LCM of the denominators will be the product x plus 1 times x squared plus 5x plus 1. Now when I divide this LCM by x plus 1, I'm going to have a times x squared plus, I'll have x squared plus 5x plus 1, and I'm multiplying that by the numerator a. When I divide this LCM by x squared plus 5x plus 1, I'll get x plus 1 and I'll multiply that by the numerator bx plus c. So that simply means bx plus c times x plus 1. Now that means 2x squared minus 3x plus 1 equals a times x squared plus 5x plus 1 and then plus bx plus c times x plus 1. Now, is there anything I can do to eliminate two constants so that I'll be left with only one, which I can then solve for? Let's see, if I put x equals minus 1, certainly this will be 0 and the whole of this will be gone. So I'll be able to get a. Yeah, that's what I'm going to do. So putting x equals minus 1, 2 times minus 1 squared minus 3 times minus 1 plus 1 equals a times minus 1 squared plus 5 times minus 1 plus 1, because I know that the whole of this will become 0. So that means minus 1 squared is 1 times 2. That's 2. Minus 3 times minus 1 is plus 3. This is 2 plus 3 plus 1, which is 6. 5 plus 1, that's 6. So that means the left hand side will give me 6. And here, minus 1 squared is 1. 5 times minus 1 is minus 5 plus 1. That's 1 minus 5, which is minus 4 plus 1, and that's minus 3. So that's minus 3 times a, which is minus 3a. You have to be very careful here. Minus 1 squared is 1. 5 times minus 1 is minus 5 plus 1. And that's going to give us minus 3. Minus 3 times a is minus 3a. So a equals 6 over minus 3, which is minus 2. If I divide both sides by minus 3, a will be equal to minus 2. That solves for a. Now, what else can I do? There is no value I can put in this equation or identity to eliminate 2 of the constants and be left with only 1. So in that case, if you say that there's no value, or you say that it will be a bit clumsy if you substitute a value, you can just substitute a very, very small value for x, which will make the equation simpler. And then you can put the value you have already got. You can put the value you have already got and make the equation. You can put the value you have already got and then think of a way to solve for the unknowns. So that's what I'm going to do here. I want to put x equals 0 in the identity, just to simplify it. So 2 times 0 squared minus 3 times 0 plus 1, that's what I'm going to have on the left hand side, equals a into bracket 0 squared plus 5 times 0 plus 1 plus b times 0 plus c times 0 plus 1. I'll put 0. Okay, I substituted 0 for x in that identity, and that means this is 0, this is 0, this is 0. So I'll be left with 1 on the left hand side. 1 equals 0 plus, this is 0, 0 plus 0 is 0 plus 1. That's 1, 1 times a. And here, this is 0, I'll be left with c, this is 1. So this simply means 0 plus c, that's c, times 0 plus 1, that's 1. C times 1 is c. And that's what I'll be left with. So that means 1 equals, I already know a, which is minus 2 plus c. And that simply means 1 plus 2 equals c, which means c equals 3. Now I know c. So I'm going to substitute another small value for x in the identity to get b. That will make the equation simpler. And I'll substitute the values of a and c into the simpler form of the equation to get b. So that's what I'm doing. Let me put x equals 1. 1 is also a very small value. X equals 1 in this equation. Just to make it simpler, if I put x equals 1, maybe I should copy it so that it can be clear how the substitution is done. Yeah, let's paste it here. Yeah, beautiful. That's the identity. Now I'm putting x equals 1 in it. That means 2 times 1 squared minus 3 times 1 plus 1 equals a into bracket 1 squared plus 5 times 1 plus 1 plus b times 1 plus c times 1 plus 1. And that simply means 2 times 1 squared is 2. That's 2 minus 3 plus 1, which is minus 1 plus 1, and that's 0. The left hand side will give me 0. And on the right hand side, I'm going to have, this is 1 plus 5, that's 6 plus 1, that's 7. 7a. You have to be very, very careful with this expansion. Now b times 1 is b plus c. So I'm going to have b plus, that simply means b plus c times 2, which means 2b plus 2c. That's plus 2b plus 2c. Now the equation is simpler, and I already know the values of a and c, so I can substitute them in this simpler equation to get b. Yeah, I can put them in. I can substitute them in the simpler equation to get the value of b. Yes, so that simply means 7 times 7a. A, what's a? A is minus 2. That means 7 times minus 2 plus 2b plus 2 times c. C is 3 equals 0. And that means minus 14 plus 2b plus 6 equals 0, which means 2b minus 14 plus 6 is minus 8. Yeah, that means 2b minus 8 equals 0. And that means 2b equals 8. When you move minus 8 to the right hand side, it becomes 8. Yeah, which simply means b equals, you divide both sides by 2 to get b. And that simply means b equals 4. B equals 4. Now we've got all of the constants. We've got all of the constants. Yeah, the constants are a, b, and c, and we've got all of them. So we can now write the partial fractions. Let me copy that. That means this fraction is the same as, is equal to a, which is what? What's a? A is minus 2. That will be minus 2 over x plus 1 plus bx plus c. What's b? B is 4. That's plus 4x plus what's c? Plus 3 all over x squared plus 5x plus 1. And that's it, very, very, very simply. That's it, very, very simply. That was a bit long, but I don't think it's difficult. So that's how you are going to be doing that. Okay, I think we should take one more. Let's take just one more. Let's take just one more. Let me take this. This is another example. Resolve x squared plus 1 over, no, that's not the one I want to take. 5 plus x over 2x squared plus 3 times x minus 1 into partial fractions. Here we can say that the first factor at the denominator is a quadratic factor and it cannot be factorized, so we are assigning the general linear factor to the numerator of its partial fractions. So that will be ax plus b over 2x squared plus 3. The second factor is a linear factor, so we'll just assign a constant to that, but I can't use a and b anymore because I already used them. So I'll use c plus c over x minus 1. Now we can continue. The LCM of the denominators is 2x squared plus 3 times x minus 1. Now when you divide that LCM by 2x plus 3, you're going to get x minus 1, and you multiply that by the numerator. By the numerator ax plus b, which means ax plus b times x minus 1. I need to move that to the left. Yeah. Now when you divide this LCM by x minus 1, you'll be left with 2x squared plus 3. And we multiply that by the numerator c. That means c into bracket 2x squared plus 3. And that means the numerator 5 plus x on the left hand side is equal to the numerator on the right hand side, ax plus b times x minus 1 plus c times 2x squared plus 2 times 2x squared plus 3. Now what do? If I put x equals 1 in this identity or this equation, this will be 0 and then the whole of this will be 0. So I'll be able to get the value of c. So let me do that. Putting x equals 1, 5 plus 1 equals a times 1 plus b. No, I don't need to write this. I already know that the whole of this will be 0 if I put x equals 1. The whole of this will be 0 if I put x equals 1 because this is 0. So the whole of this will be 0. So if I put x equals 1, 5 plus 1 equals c into bracket 2 times 1 squared plus 3. And that means 6 equals 2 times 1 squared is 2 plus 3, that's 5. And that's 5c. So c equals 6 over 5 if we divide both sides by 5. Now what can I put in the identity to eliminate maybe a and c to get b, or b and c to get a? I can't see I can't see anything. So at times there's a value you can substitute to get one of the remaining unknowns or constants. But if you say that it might look a little clumsy, you can just substitute a very small value that will simplify the equation. So that's what I'm doing here. I'm putting x equals 0. That means 5 plus 0 equals a times 0 plus b times 0 minus 1 plus c into brackets 2 times 0 squared plus 3. 2 times 0 squared plus 3. And that simply means 5 plus 0 is 5 equals a times 0 is 0. 0 minus 1 is minus 1. And we're left with b here. So b times minus 1 will be minus b plus 2 times 0 is 0 plus 3 is 3 times c plus 3c. Now I already know the value of c, so I can use that to find b here. So that means 5 equals minus b plus 3 into bracket 6 over 5. That's the value of c, which means let me bring b to the left, minus b to the right hand, to the left hand side, and it becomes plus b, and I'm taking 5 to the right hand side. That will be minus 5 plus, this is 18 over 5, and that's simply minus 7 over 5. You can work that out. That's what you get. B is equal to minus 7 over 5. Minus 7 over 5. Now I have the constants c and b. I'm only left with a. So let me copy the identity and think of another small value to substitute in it to make it simpler. This is the identity. Now I want to put x equals, I've put 1, I've used 1 as 0. Let me put x equals minus 1. If I put x equals minus 1, that simply means 5 minus 1 equals a times minus 1 plus b into bracket minus 1 plus c into bracket 2 times minus 1 squared plus 3, which means 5 minus 1 is 4 equals a times minus 1 is minus a plus b. That's minus a. No? Okay. And what I have there, that will be minus a plus b times minus 1 minus 1 is minus 2. This is minus a plus b and then times minus 2 That's minus a plus b times minus 2, which would be plus 2a. I'm expanding these brackets now. That's minus 2 times minus a, that's plus 2a. Plus 2a minus 2 times plus b, that's minus 2b. Now here, 2 times minus 1 squared is 1 times 2, that's 2 plus 3, that's 5 times c, that's 5c. Now I can put the values of, substitute the values of b and c to get a. So that simply means 4 equals 2a minus 2 into bracket minus 7 over 5 plus 5 times c is 6 over 5. 5 times 6 over 5. And that simply means 2a. This will be plus 14 over 5. I want to make the denominator 5. So that's plus 30 over 5. So I can easily add the two fractions. So that means that's equal to 2a plus 44 over 5. So that simply means 4 equals 2a plus 44 over 5. Now, I can say 2a, I'm bringing 44 over 5 to the left-hand side. So it will mean 4 minus 44 over 5 equals 2a, which is the same as 2a equals, or let me even do that. 4 minus 44 over 5 equals 2a. And this simply means minus 24 over 5 equals 2a. So when you divide both sides by 2, it's going to become, dividing both sides by 2, a will be equal to minus 24 over 5 divided by 2 means times 1 over 2, and that's minus 12. Of course, 12, 2 here, 1, 2 here, minus 12. That's minus 12 over 5. Now we have found all of the constants. We can now write the partial fractions, and we can write the partial fractions. So that therefore means 5 plus x, this compound fraction, is the same as a, which is, okay, that's ax plus b. Let's see, it's ax plus b over 2x squared plus 3 plus c over x minus 1. So that's minus 12 over 5 into bracket 2x squared plus 3. What am I writing? It's supposed to be ax plus b. So that's going to be minus 12. This might look a bit tricky. Minus 12 over 5x plus b. What is b? B is minus 7 over 5. Plus b will simply mean minus 7 over 5 all over, that's ax plus b, 2x squared plus 3. I'm writing it this way to make it so that you don't find it clumsy and it can be clear. Plus c over x minus 1. What is c? C is 6 over 5. That's plus 6. Since I'm writing the fractions at the numerator, let me write that too. That's 6 over 5 all over x minus 1. So that's the same as, of course, minus 12 over 5x minus 7 over 5 is the same as minus 12x minus 7 over 5. So if I divide that by 2x squared plus 3, it is simply the same as minus 12x minus 7 over 5 into bracket 2x squared plus 3, and then plus 6 over 5 times x minus 5 into bracket x minus 1. So that's it, very, very simply. Let me make that, write that on a single line. 5 plus x over 2x squared plus 3 times x minus 1 5 plus x equals minus 12. If you like, you can even arrange it this way: 6 over 5 times x minus 1. Okay, I think I want to leave it this way, simply minus 12 minus, I don't want to make anything look complicated, because there is another way I can write this, but let me leave it this way: plus 6 over 5 times x minus 1. And that's it, very, very simply. So this example, the examples here are on fractions whose denominators have non-factorizable quadratic factors, or non-linear and non-factorizable factors, and we have seen how to do that. So we're taking another technique in the next one. Thank you very much for your time, and I'll see you in the next. Bye bye.